This is a question from J Main 2026. Let the symbol denote the greatest integer function, and if the domain of the function fx is sine inverse within bracket x plus greatest function of x upon 3 is alpha beta. This shows that alpha is included and beta is not included. Then alpha square plus beta square is question mark. So let us see how to solve this. First of all, you know that the domain of the function sine inverse x, if you have this function sine inverse x, okay, in that case x lies between -1 and 1, isn't it? This information you already know. Using this, we will compare the given function, which is sine inverse x plus rotational function of x upon 3. In this case also, your x will lie between mine. X means here, what is the meaning of x? This is whole is x. So this will lie between -1 and 1. So x plus rotational function of x divided by 3 lies between -1 and 1. So on multiplication with 3 throughout, -3 less equal to x plus rotational function of x less equal to 3. Now one more information we know about greatest integer function is that x can be written as greatest integer x plus fractional part of the x. Using this, we will do the substitution over here for the x. So this will be, in place of x I will write greatest function of x plus fractional part of x plus greatest function of x less than 3. This will imply -3 less equal to twice of greatest integer function of x, this and this, plus fractional part of x less equal to 3. Now we will find out the upper limit and lower limit for x. So just for the upper limit, if we are talking, okay, for upper limit, let us start. Now if x, greatest value of x is 0, in that case you know that x will be less equal to 0 and less than 1, then only the greatest integer value for x will be 0. So suppose this is the condition, then our inequality, which is here, sub equation 1, equation 1 will give you that -3 less equal to twice of 0, twice into 0, plus greatest integer, sorry, fractional part of x less equal to 3. So this will give you -3 less equal to fractional part of x less equal to 3. Now from this you can conclude that this inequality includes the values, at least those, all those values which lies between this 0 and 1. Yes or no? This interval, suppose you have this interval -3 and 3, so it is containing all those values which are between 0 and 1. Yes, -3 and 3 if you have. So this is containing this, all these values already. So this interval is having all those values for x which satisfies the above inequality. So from here we are getting that x will be less than 1, not equal to 1 but less than 1. So just find out. Therefore x will be less than 1. We are finding out the upper limit. For that reason will be less than 1 but not equal to 1 also. Okay, but not equal to 1. Come to the next point. If this greatest value is 1, so in this case what happens, x will be 1 and here there will be, means x will be greater than equal to 1 and less than 0 2. Okay, then only the greatest value of x will be 1. Suppose you have 1.5, so greatest value of 1.5 is 1. You know greatest integer definition, it gives the immediate lower integer. Okay, so in this case what happens to your inequality 1, equation 1, let us see, minus 3 less equal to 2 into 1 plus fractional part of x less than 3. So this will give you minus 3 less equal to 2 plus fractional part of x less equal to 3. So minus 3 minus 2 less than fractional part and 3 minus 2 here. By this you are getting this situation. So what you are getting in this, that fractional part of x is greater equal to minus 5 and less equal to 1. So less equal to 1, it is not possible. The greatest integer function is less than 1. Okay. So, but less than 1 is possible. Means here in this interval also, this greatest integer function, if this is the situation, this is already contained in this interval from 0 to 1. Okay. So this we will also, we can take this interval also. Okay. So from this we are concluding that x will be less than 2. From this we are concluding that x will be less than 2 and not equal to 2. So let us write that also. Therefore x will be less than 2 but not equal to 2. Now come to the next, where we are going to take a break, that we have to decide. Now if greatest integer value is 2, what happens in that case? X is 2 and this is lying between 2 and 3, where 3 is not included. Suppose 2.7, greatest integer value is 2, immediate lower integer. So in that case our inequality will give you 3 less equal to 2 into 2 plus this less equal to 3. This time minus 3 less equal to 4 plus greatest, sorry, fractional part of x, and this is your less than equal to 3. So minus 3 minus 4 less equal to fractional part of x less equal to 3 minus 4. Here you are getting minus 7 and fractional part of x less equal to minus 1. Here is, you have to take a break. Why? Fractional part is lying between minus 7 and minus 1, which is not possible. Why? Because fractional part is like this. It is once the first more expression is that x will be a positive 1. So here entire range is not giving you any positive value. Okay. For that reason also you can cancel out. Okay. This is the only reason. So this interval we will, this value we will not take. So this interval we will not take. So from here we are not getting any value which is x is having as its domain and upper limit also. So we will just discard it. So let us discard this. Now we will find the lower limit. So we will discard this interval. Okay, so full stop. Now we will come to the for the lower limit for x. So let us see. Same way for lower limit. So we have to move to x equal to greatest value of x equal to minus 1 if, because we have started from 0. So in this case x will be your lying between, if it is minus 1, so minus 1 and between 0. Okay, then suppose you are getting minus 0.5, so its greatest lower integer is minus 1. So this is the interval. Now in this case what happens to your inequality? Your inequality says minus 3 less equal to 2 into this value minus 1 plus fractional part of x less equal to 3. So this will give you minus 3 minus 2 plus fractional part of x, and this is your 3. Minus 3 plus minus 3 plus 2. Now here fractional part x, 3 plus 2. So you are getting minus 1 fractional part x and 5. So again here this interval fractional part is already contained in this interval, so we can use this interval. So lower limit can be minus 1 here. So we'll, because you see 0 less equal to x less than 1, so this is contained in this interval. Okay, so x will be greater or equal to minus 1. Okay, now come to the again where we are going to take a full stop. That point also we have to check. So if greatest new value is minus 2, in that case minus 2 less equal to x less than minus 1. Okay, so in this case what is your inequality? Minus 3 less equal to 2 into minus 2 plus fractional part x less equal to 3. So minus 3 minus 2 2s are 4, so plus 4 if you will bring it. I am doing it directly. So 3 plus 4, this is 1, this is fractional part of x, and this is 7. So this time you are able to see that your interval 0 x less than 1 is not contained in this. Yes, as we have discussed it for the upper limit, same discussion we have done here, we are doing the same discussion. So we will discard this interval. Therefore we will discard this interval. So what is your lower limit? Your lower limit is minus 1. Okay, and what is your upper limit where we have taken the break? This one. Okay, 2. X will be less than 2 but not equal to 2. So our interval is the domain. Therefore domain will be of the form x will be greater or equal to minus 1, that means minus 1, and less than 2. So this is, and this was given in your question, that alpha and beta like this. Therefore, alpha is your minus 1 and beta is your 2. You have to find alpha square plus beta square. So minus 1 square plus 2 square, that is 5. This is the value. Thank you.